Alright, so Konnichiwa, JSConf Japan. So first of all, I would like to give a huge shout out to the organizers of this conference for setting up the amazing event. So thank you everyone. And today I'm going to talk about text containers in Canvas. Well, text containers are one of the most widely used features when it comes to whiteboard. Be it, a lot of you would have used text containers when sketching some layout diagrams, some architectural diagrams, some roadmap. And today in my talk, we are going to deep dive into how these text containers work under the hood in Canvas. And I'll be also sharing some insights on how it's built in Excalibur, which is a free and open source Canvas-based editor for sketching hand-on-like diagrams. So any of you have actually used Excalibur?
誰かがエクスカリドラを使った人はいますか？聞いたこと？
Oh, nice. That's great to see. So yeah, who have not seen, do check out. Just go to excalibur.com and let me know what you think. So before I start the talk, let me just give a quick introduction about myself. So I'm Aakansha. I'm a front-end developer and a FOSS enthusiast from India. FOSS basically stands for Free and Open Source Software, and I work with the Excalibur core team. And I also lead the FOSS meetups in Bangalore, India. And one of the main agenda of these meetups is to mainly promote the FOSS community in India and build a strong FOSS ecosystem in India. And yeah, I would love to connect with all of you in socials. If you want to talk about front-end, JavaScript, open source, anything, I'm all in for that. So you can also scan that QR code for me connecting with socials.
ソーシャルでインドの方でオープンソースコミュニティを流行ってます。ぜひ接続してください。
So yeah, with that, let's get started with the talk. So what exactly is a text container? Well, text container is basically any shape to which you can attach some text. It can be a square, an ellipse, a diamond, or any custom shape where you can add the ability to attach some text. That is basically a text container. So this is the regular text and this is the container. Now when we combine both of these, it becomes a text container. So you can see that the text which was outside, it's actually getting wrapped inside the container. That's what a text container is. So for the users, it would look like, hey, it's just a rectangle with some text, but underneath, these are two separate elements. The rectangle is a separate element and the text is actually a separate element. So now that we are going to deep dive in building this feature and how it works, so let's make a note of it that these two are actually separate elements. And whenever all of us, when we build some feature, the first exercise which we do is, jot down the minimal basic requirements which we need to build this feature. So let's look at the minimal requirements in building this feature. So the first requirement is that the users should be able to attach a text to a container. So we need some UI in the app so that the users can attach the text to a container. The next is, number two is that we need a way so that we can link the text to a container so that we know that, hey, this container belongs to this text and this text is attached to this particular container. So some relationship. Third is that the text should no longer be treated as an individual element because now whatever actions you are going to apply to the container, let's say moving the container, copying the container, those actions should be replicated to the text element as well. And the fourth and the most important point is that the text should always stay inside the container bounding box. So these are the four requirements which we are going to consider in building this feature. And we'll be deep diving into each of it and fulfill it one by one. But before that, let's actually decide how we want to represent an element on the canvas. How we want to structure an element on the canvas. So let's actually look into that first. So this is basically the bare minimal JSON structure which we will be using to represent an element in the canvas. It has an ID which helps you to uniquely identify the element on the canvas. The type of the shape, it can be rectangle, square, ellipse, whatever the shape is. X, Y are the coordinates to position the element on the canvas. Width and height are the dimensions of that element. Rest all are the properties for mere decoration, so we can ignore it. And this is like, let's consider this particular JSON structure. We'll be using this to represent an element. And now since we have decided the structure, let's actually go into the requirements which we just discussed a while ago. So the first requirement is we need a UI for the user so that they can attach the text to the container. Now, this is one of the most common features when it comes to whiteboard. And if you have used Excalibur or Figma or any whiteboard, you would have seen that one of the most intuitive ways to attach the text to a container is you select the container, press enter and start typing. And this text actually gets attached to that container. And so this is one of the intuitive ways, let's consider this as one of the ways. So for the keyboard users, we can say that pressing enter on a selected container can be one of the ways. For mouse users, maybe double click on the center of the container. Maybe some way with context menu you want to have. Maybe some UI button somewhere in your app which helps you to attach the text to a container. Or maybe something else which is not even listed here. We are just discussing the use cases. So we are not really going to deep dive and build all of this. That's not really needed. But the reason I'm mentioning all of this is that there is one common thing among all of these requirements. And that is, to implement any of these, we first need to identify the target container in the canvas. We first need to understand which container the user is targeting on the canvas. And since it's a canvas, you cannot really inspect anything from outside. Whatever you draw in the canvas stays inside the canvas. You cannot really say that, let's add an event listener and we will be able to make all of these things work. Canvas doesn't work like that. It's like a black box. So let's understand how we can identify the target container. So let's consider this particular container which the user is targeting. It has some XY coordinates and some width and height. And this is the user coordinates where the user is clicking, A, B. Now, what we have to do is we need to identify that whether this point is actually inside this container and how are we going to do that. So there are a lot of elements in the canvas and every element has these XY coordinates. So what we can do is we can loop through all the elements in the canvas and we can check, does this A, B coordinates fall in the range of any of these elements? So if it is between x plus width, y plus height, then I can say that, hey, the user is targeting this particular rectangle in the canvas. So this sounds fair. Now let's look into the implementation of it. I have a quick demo to show this. Again, let's assume that this is the container which the user is trying to target. What we are going to do is, when I click inside, I want to show some selection indicator, and when I click outside, that indicator should be gone. That's what we are going to do. So I have this function here, is hitting container, which is exactly doing the same thing. It is basically checking the client coordinates is within the range of this container, container.x, container.x plus width, container.y, and container.y plus height. So we are just checking whether this client xy are within these coordinates. If it is, let it return true, else return false. So since I'm continuously mentioning that user is clicking on the canvas, so the first thing which comes to our mind is, okay, let's add the click listener on the canvas and let's just check if it's hitting the container. So let's do that. I already have the click listener right here, and what I'm going to do is I'm just checking if it's hitting the container, and if it's hitting, let's render the selection indicator, else let's clear it, right? So now let's see what happens. I'm clicking inside, it's a hit. You can see that container is hit. That is the selection indicator. Outside, it's not a hit. It's a hit. It's not a hit. It works well. Let's do some more testing. Is this a hit? This is not a hit. I'm actually trying to drag, right? Is this a hit? It's not a hit. So this means this is a false positive. We cannot use a click listener here because it is giving this false positive. I'm actually trying to drag something, but it is actually predicted as a hit. So what we can do about it, and why is this happening? So the reason it is happening here is, when I press the mouse button, pointed down event is getting triggered. When I'm moving, the pointer move is getting triggered. But when I'm leaving the mouse button, pointer up is getting triggered, and after that, click event gets triggered. That is the reason this is becoming a false positive. So clearly we cannot use the click event here. But the pointer events are getting triggered, right? So let's try to use this pointer events. What if I can calculate the distance between these 2 points, the pointer down and pointer up coordinates, and if I can check whether the distance between the pointer down and pointer up coordinates is within some threshold, let's say 10 pixel. If it is within some threshold, let's say 10 pixel, I'll consider it as a hit, else it's not a hit. So for this, it's definitely more than 10 pixel. It's a drag, so it will be considered as a drag. But let's say if I click somewhere here, the pointer down and pointer up coordinates are very close to each other, so it will be like close to 0, so it will be considered as a hit. Let's try this out and see if it works. I'll comment this part because it's not needed anymore. And I already have the pointer down and pointer up coordinates. So what I'm doing here is I'm calculating the distance and I'm checking if it is less than or equal to 10. That's the threshold. And if it is hitting the container, let's actually render the selection indicator, else let's just hide it. So let's see if this works. Inside, it's a hit. Outside, it's not a hit. It's a hit. It's not a hit. Now let's do again some more testing. Is this a hit? It's not a hit. Is this a hit? It's not a hit. So this works. This is what we want, right? So this is how we can actually determine the target container which the user is actually trying to target on the canvas. And this strategy of determining the hit region in the canvas is known as hitbox testing. So let's go back to the slides. Once we do this, we can actually identify the target container, and then after that, you can add the keyboard listener, mouse listener, whatever the way you want. And once that is done, we have identified the target container, we can actually add just a text area on top of the canvas so that user can start typing. And it's basically position absolute because you are placing on top of the canvas, and so that user actually gets the feel that they are actually typing on the canvas and not really some DOM element. That's the reason all the stylings are removed. You can see margin 0, padding 0, border 0, outline 0, so that the user gets the feel that they are actually typing in the canvas. So yeah, with this we actually fulfill the first requirement. We have done with the first requirement. Now let's jump to the next requirement, and that is we need a way to link the text and its containers so that in our code base we know that this container belongs to this text and this text is a part of this particular container. So for that, let's do some assumptions. A single text can belong to a single container. That is the first assumption. A single container can have single text, and that basically means that it's a one-on-one relationship between the text and its container. So with this in mind, let's actually look at the JSON, the text element JSON. So again, this is the same JSON which I just showed you a couple of minutes back. Apart from, we have just added the text related attributes, the text align, font size and all those stuff. So let's consider this as the text element JSON. And now that every element has a unique ID, we know that, and by looking at this JSON, I want to identify whether it's a regular text or is it a part of a text container. So what we can do is we can just add an attribute container ID. This container ID is basically ID of the container to which this text is attached. And now when I look at this JSON, I can say, hey, does this have a container ID? If it has, it's a part of text container. Otherwise, it's a regular text. So one-way relationship is done. Now let's look at the other end. Let's look at the container JSON as well. So now this is the container JSON. Now same thing applies here. By looking at this container, I should be able to identify whether it's a regular container or is it a part of a text container. So the same thing we can do here. Let's just add a bound text element ID, which is the ID of the text element where the text is attached to this container. So again, the same thing. If I look at this JSON, container JSON, and if it has a bound text element ID, it is a text container, otherwise it's a regular container. So with this, second requirement is fulfilled as well. So let's then jump to the third requirement. The third requirement says that whatever actions you are applying to the container, those should be replicated to the text element as well. So now that we have linked the text and its container with the help of container ID and bound text element ID, what we can do is, whenever I'm moving the container, I can just check, does it have a bound text element ID? Let me move the text element as well. When I'm copying the container, I can check, does it have a bound text element ID? Let me copy the text element as well. So with fulfilling the previous requirement, this requirement automatically gets fulfilled as well. So this is right now the status. As you can see, when you move, resize, the text element is also getting updated. This is right now the status of the feature. So with this, the third requirement is done. Now let's look at the final requirement. The text should always stay inside the container bounding box. Now what exactly is the container bounding box? That is something which we first need to understand. So you can see this red outline, that is the bounding box. Every shape has its own bounding box, and this bounding box can get complex with shapes. So for the scope of this talk, I'll just keep it limited to the bounding box of a rectangle, which is just a 5 pixel padding. And we need to make sure that the text never goes out of the container bounding box. And this we need to do in two scenarios. Number one is in the text area when the user is typing. Number two is in the canvas when the user exits the text editor and the user is interacting in the canvas. So we need to take care of this scenario in these two cases. So let's look at it one by one and see how we can do that. So let's look at the text area because that's the simplest one. So text area is DOM, and when it's DOM we can take the advantage of CSS. So we can just give it some width and height, and with CSS properties like word break and white space, we can actually make sure that it works. So once we do that, this is how it looks like. So you can see when you try to edit it, it's actually getting wrapped. But when you exit the text editor, it again goes to the original state because we have not implemented this in the canvas yet. So with this, we are able to make it work in the text area, the DOM element. Now we need to do the same in the canvas as well. So how we can do that in the canvas? In canvas, it's not really straightforward because in canvas you can't really say that if the text doesn't, if the text overflows, just wrap it to the next line. That is not something you can do in the canvas. So how you can wrap the text in canvas? And canvas doesn't support multi-line as well. So if you want to render multiple lines in the canvas, you have to render them individually. So keeping that in mind, what we can do is we need to imitate the text editor word wrap algorithm in the canvas. So we need to write our own wrapping algorithm so that it works the same way in the canvas as it is working in the text editor right now. And for that, there are a couple of cases which we need to consider. So we need to, the first two requirements are really important. We need to make sure that when there are longer lines, they break when they are exceeding the bounding box width. When you have longer words, they should also break when they exceed the bounding box width. The last one is a browser-specific case with hyphens that I'll cover in a bit. Don't worry about that. But the first two cases of breaking longer words and longer lines is extremely important. So let's look at the examples so that we understand it better. So this is a long line, so should break, and this definitely cannot fit in that container. So we need to break it. So it's right in the text editor, as you can see, it is breaking at word long, should, and break. And this is something we need to take care of in our wrapping algorithm. We need to make sure this breaks in this exact same way. And for longer words like internationalization, which cannot fit in the container, you can see it's breaking at character N. So again, the same thing, for longer words, we should be able to handle the wrapping. And the third case, which I was talking about, which is hyphenated words. So this is an example of hey word hyphen break. Now this should break like this because word hyphen break cannot fit in the first line with hey. So it goes to the next line. But that is something which I was assuming. It doesn't work like that. So this is not the way it works in text editor. That's why it's the weird browser behavior. So this is how it actually breaks in the text editor. It actually breaks at hyphen. So hyphen is actually treated as a delimiter when it comes to breaking the words. So this is again a specific case, and there are more cases like this which you will encounter as you do more and more testing, because it's not really documented anywhere. I could not find any such documentation where the word wrap algorithm of DOM is actually documented. So this is something which, this is one of those use cases, and we can make our wrapping algorithm more and more stronger when we encounter this. So yeah, with this we can actually make sure that our wrapping algorithm works well. We have all the instructions, so we can just code it up. So before we code it up, now I want to highlight one thing that I have been continuously mentioning, that we need to make sure that the text should not go out of the bounding box in the canvas. How can we make sure that the text doesn't go out of the bounding box? For that, we first need to know the dimensions of the text. We need to know the width of the text. Then only we can say, okay, if it is exceeding the container bounding box width, it should not go out of the bounding box. It should wrap to the next line. So how do you actually measure the text dimensions? That is the next thing. How do you measure the text dimensions in Canvas? And there are a couple of approaches to do that. The first one is using DOM measurements, which is pretty straightforward. Using hybrid measurements, which is basically a mix of DOM measurements and Canvas measurements. Canvas also has a measurement API, which I'll cover in a bit, and that's why the name is hybrid. And the third one is Canvas measurements purely. So we'll be going through each of this approach, and we will be diving into the conclusions of it, the pros and cons of each approach, and then you can take the call which approach works the best for you. So let's actually first look into the DOM measurements. So DOM measurements is the most simplest to implement. What you do is you just take a div, dump all text into it, remove all the styling so that you can get the exact width and height, and just take the offset width and height, and that is the DOM measurement. And this is what you will be using in the text editor, the DOM, and as well as in the Canvas in your wrapping algorithm. So when testing this across different browsers, this is what was observed. So if you notice, for the text hello, the height differs across the browsers. The DOM height is differing. And why is that so? The reason is that line height is set to normal. So if you don't set the line height, it defaults to normal. And this normal has different behavior in different browsers. And that is the reason of different DOM height. So the way to fix this is, we can just set the line height to some hard-coded value. 1.2 and 1.25 are the most recommended values. And once you set this thing actually gets resolved. So you can see now the height is actually same across all the browsers. So if you're using DOM measurements, this is something to keep in mind, that make sure that line height is hard-coded by you, so that the height is same across all the browsers. And let's look at the pros and cons of this approach. So the pros is, it works best with the text editor, since we are using the DOM measurements on the DOM elements. That's the best possible combination. And there will never be any discrepancies when you are switching between text editor and Canvas, because both of them are using the exact same DOM measurements. And yeah, it works pretty well across browsers, we just saw, considering you use the same line height. So these are the pros. Let's look at the cons as well. It can be expensive for Canvas, because each line, each word, and each character, if needed, has to be measured with DOM measurements. And that can turn out to be expensive. So that is something to keep in mind. And it will not work in node.js because you are using DOM measurements, so it will definitely not work on the server side. So if you want to support server side, this is something you need to be aware of. So this was about the first approach. Now let's see if we can overcome these cons in the next approaches which we are left with. So let's look at the next one, which is the hybrid measurements. So Canvas has this API called measure text, which basically gives you the text metrics, and you can compute the width with the help of this measure text API. This is how you can do it. You just set the context and font, and then you get a lot of metrics, but we are just interested in the width. This is how you can compute the width of a given text. And we are going to use this measure text API just in the wrapping algorithm. The DOM will still stay with the DOM measurements, and that is why the name is hybrid. So with this, when comparing the behavior across different browsers, Again, if you notice the width when using the canvas measurement, it is slightly differing across the browsers. And why is that so? Well, we cannot really do anything about it because this is the nature of the API. The measure text API is unfortunately not consistent across the browsers. So you need to be aware of this if you are using the measure text API. So yeah. And next I would like to show you a quick demo to compare the canvas and the DOM measurements. So let's just go to the demo. So I have this huge text, and what I'm going to do is I'm basically computing the width of this entire text by splitting it into words and summing it up, and this I am doing 10 times so that I can compute the average time taken by DOM to compute the width and average time taken by canvas to compute the width, and so that we can get better accurate results. So let's see how it works. Let's try it out. So you can see the average DOM time is 5.96 millisecond and average canvas time is 0.67 millisecond, which is like 89% faster already. Let's try it more, 91% faster, 90% faster. So on an average, it's close to 90% on this browser and device. So, and this is like a very huge improvement. So I can say that, hey, canvas measurement is 85 to 95% faster than the DOM measurements depending on the browser and device. And the con is, I just showed the discrepancy cross browser, so that is something to be aware of, and you might have to add some offset to take care of it. So that is something you need to know. So this was about the hybrid measurements, and with this we can say that the expensive part, the con, is completely gone. We had a huge win over it with the help of measure text API, and it's like very lot faster, 85 to 95% faster. So we don't need to worry about it. But it will still not work in Node because we are still using the DOM measurements in the editor, text editor. So that is something we are left with, and let's see if we are able to overcome this in the last approach. So canvas measurements. In this case, we are using only canvas measurements. We are completely moving away from DOM measurements. So we need a way to compute the width of the entire text. Till now, we were using the measure text API in the wrapping algorithm, but now since we are moving completely away from the DOM measurements, we need to compute the width of the entire text using the measure text API, and we also need a way to compute the height of the text as well. So let's see how we can do that without DOM measurements. So when it comes to width, since canvas doesn't support multi-line, what we can do is we can just split the lines and we can compute the width of each line, and whichever line has the maximum width, that is the safest width to assume for that entire text. In this case, page when looking at it has the maximum width. So this width we can actually consider for this entire text. And that is how we actually move away from the DOM measurements when it comes to the text, when it comes to the width. And for the height, what we can do is, again, we are splitting it into lines. We already are hard coding the line height as 1.25. So we can actually multiply it with the font size to convert it into pixels. And we already know the number of lines, so just multiply it with the line count. That is how you can actually compute the height of this entire text. So this way we can actually move away completely from the DOM measurements, and we use the canvas mix of our own heuristic and canvas measurements. And with this, we overcome the last con, which is it will now start working in Node because measure text API of Canvas is supported in Node.js. And this is the overall conclusion of the three approaches. DOM measurements is the best when it comes to discrepancies between text editor and cross-browser. And Canvas measurement is a huge win when it comes to performance and the Node.js support. Depending on your use case, you can actually take the call which one you want to go ahead with. But yeah, in Excalibur, we do use the canvas measurements. And with this, I would like to just talk a little bit about the performance improvements which we can do to make our algo and feature more faster. So we can actually store the wrapped text in the text element JSON as well. So let's say when you are just moving the containers, you don't need to call the wrapping algorithm every time. So this is like a optimization layer. Now every language has a limited character set. So in long words, there is a huge chance that those characters will be repeated. So we can actually start caching the character width. And this will again be a huge improvement. And let me just show you a quick demo for this. So again, this is the same huge text which I showed you a couple of minutes back. But in this case, instead of splitting it into words, I am splitting it into characters and computing the width of this entire text by summing the individual dimensions. And this I am doing with cache and without cache. So as I run it more, it will start using the cache. So let's see how it behaves. So for the first time, without cache, it is taking 4.9 milliseconds, and with cache, it is just 0.4 milliseconds. So it is already 91% faster. And as you use this more, the cache will be used more, so it should be more faster. It is 92% faster, 93. So you can see that it is like 90% faster at least on this device. And this is again a huge improvement as well. So yeah, I can say that it's 85 to 95% faster on this browser and device. And yeah, we can also use the wrapping techniques like binary search, algorithms like binary search to find the breakpoint faster. So this is again an improvement. There are a lot more improvements, performance improvements, which I cannot cover in the talk, but yeah, these are some of it. And with this, I would like to wrap up with the takeaways. We learned about hitbox testing to identify the target container on the canvas. Canvas doesn't support multi-line, so that needs to be handled. We need to imitate the text editor word break behavior on the canvas. And canvas measurements is of course a huge improvement over DOM measurements with the support of node.js as well. And with caching and techniques like binary search, we can make the algo more faster. So this is basically the repo with all the demos I showed. You can scan the QR code, or you can just go to this link and you can try it on your device and browser and share how it works for you. So that was all from my side. Thank you so much, and it was great to be a part of JSConf Japan. And Martin is not here, but I would like to thank Martin who helped in reviewing the Japanese translations in my talk. So yeah, thank you everyone. Arigato, and let me know if you have any feedback or questions. I'll be here around. So yeah, thank you so much.